We're now going to start examining interventions. So the classic way to capture interventions is through different experiments. So in this case, we have only a single parameter, I think, in main, which is the population size right now. That's okay, but we're going to add another 2 parameters to main. Okay, so let's go to main, and let's add in a convenience. Here, let's add in to main convenience preference for convenience stores. Actually, let's just call it min preference for convenience stores and max preference for convenience stores. We're going to try to change, instead of having it go from 0 to 1, we're going to have it go from this min to the max. And we're going to have different, so we're going to try to shift for some interventions the value to use here, okay, for preferences for convenience stores. So I just copied it here, but what I have here, ladies and gentlemen, is min preference for convenience stores and max preference. And the default values will be for max 1 and the min 0. 0. Okay? Okay. Now, for the population, so who wants a little bit more time for that? A little bit more time? So min preference, so this is in main, min preference for convenience stores, max preference for convenience stores. Okay? Okay. A little bit more time? Okay? Ladies and gentlemen, I made min, the default value 0, max, default value 1. For the population, ladies and gentlemen, I would like you to now, instead of for preference for convenience store meals being 0 to 1, I'd like it to go from min preference for convenience stores to max preference for convenience stores. Let me put that up on the big screen. This is for the population, and it is, I will, I'll sort of put it on 2 lines so you can see this. Okay, it's up here, ladies and gentlemen, with in the population and how we draw a value to set their preference for convenience store meals. We're going to draw it between this min and the max. And that's going to be specified on per intervention basis, per experiment basis. Okay. Are we okay with that? Okay. So, ladies and gentlemen, first, just as a very simple alternative scenario, we're going to rename simulation to be baseline. The baseline scenario. The scenario where we haven't changed anything. It's kind of business as usual. In any case, it's a reference scenario. It's not always business as usual, but often it serves as that. It's kind of the current scenario. Next, for the GIS food environment, we're going to add to this model, I'm going to add a new simulation called weakened convenience store preferences, and we'll call this entire population. So across entire population. Okay, so basically we're going to try to get people to prefer not eating at convenience stores. And here the min preference for convenience stores will be 0, the max preference would be 0.5 for this weakened convenience store. So here we've shifted the population in terms of the level of preference for convenience stores. The baseline is 0 to 1, whereas here for this one it's 0 to 0.5. The max preference for convenience stores is 0.5. Okay? That might be a way that we would shift for a sort of a non-targeted intervention. We change a parameter value between experiments where this would represent an alternative scenario with a certain new policy regime in place. And we posit that we'll be changing the preferences. So we want to investigate that. But now, in the closing minutes, I would like to show you how you create a targeted intervention. Can we do that? Okay, ladies and gentlemen, we'll do the following. Okay, so I would like you to go to main, and I would like to add something there that is new, something there that is unfamiliar. It will have the veneer of familiarity, but at its heart, it will have profound power and be unfamiliar. So, in the palette, I would like you to add something that seems familiar and innocuous. I would like you to add a parameter. And this parameter, in the first taste of what lies to come, will be called is eligible for intervention. Okay? Next, I will add a parameter. Well, okay, sorry. Well, we'll fix this one up first. So is eligible for parameter, though, is no standard parameter. We will make it a Boolean. And you may think we're passing just a thing saying, are people eligible for interventions? Far from it. We will do something else. We will do something, ladies and gentlemen, that should do you proud. We are going to make this, using the Advanced tab, something called a dynamic parameter. Now, what that means is, in essence, that we're passing in not a value, but a function to compute values. Okay? And this function is going to take in an argument that is going to be called person. And they will be of type, well, what do you think? If they're named person, what do you think the type they are? Or a person. So its job in life is going to be to tell, is this person eligible for an intervention? And each experiment is going to be able to specify a different rule for whether or not someone's eligible for an intervention. For one experiment, we'll say no one's eligible for the intervention. Another one, we may say everyone. Another one will say only those who live in this area of the city are eligible. Or another one, only those between this age group and this age group with this life circumstance in the past are eligible. That, ladies and gentlemen, is true power. Okay. Okay. So, ladies and gentlemen, having done this, I would like now to specify a default value for this parameter. Okay? The default value for this parameter is going to be the simple value false. Okay? Okay. Great. Okay. Next. So by default, no one's eligible for the intervention. Are we okay with that? Next. Okay. Man, they didn't see this last week. You should tell them that. Okay, drag in here. The next thing is going to be perform intervention on person. Okay? On person. So if a person is eligible, this is how we're going to perform the intervention on them. And this too, ladies and gentlemen, sorry, I forgot to, yes, I did set it to be a Boolean, this previous one. And this one, by contrast, will be what's called an action parameter. Not in advance, we'll know it's like dynamic, but action parameter. This parameter, by default, will do nothing. So we leave blank action. It will take in a person as its argument, and it will be of type person. Okay? Type person. The minutes tick down, but the crown of glory is already yours. Yes?
I can't find action. Yeah.
Okay. TAs deploy. Okay, down in the advanced area. Okay, where was it?
Just under the advanced tab.
Okay. Yeah. That's down here. And dynamic was down here for the other one there, too. So just to show you the two of them, there's this one, perform intervention on person. It takes a person, a type person. It's an action parameter. Its default action is blank. And then is eligible for intervention. It's of type Boolean. It is a parameter that's a dynamic parameter. It takes person in. It's a type person, and its default value, ladies and gentlemen, is false. Now, these things are going to determine who gets delivered the intervention. There's going to be a final element required, and then we can apply them. Can I show you this element? I'd like you to drag in an event. And this event is going to say perform intervention. Okay. This event right now is going to occur only once at the beginning time. Now in general we might set it to occur multiple times, once a month, what have you, once a year. But right now it's going to perform once at the beginning of the model. And this is going to do something. And this is going to do something that you haven't seen before. It's going to go through each person in the population, and it's going to see if they're eligible. And if they are eligible, it's going to perform the intervention on them. Is that okay? If no one's eligible, no one will have anything performed on them. If everyone's eligible, every single person will have something performed on them. If only a subgroup is eligible, just that subgroup will have the intervention performed on them. Are you ready? Okay. This will stretch you. Dylan and Annie, prepare for deployment. All sectors. Okay? Monitor all sectors. Okay. For person, for each person in the population, we'll call them person, if is eligible for intervention for that person. Okay, yeah, okay, fine. Then perform intervention on person of that person. This is what I'm doing. And I will put it up, ladies and gentlemen, on the big screen. For each person in the population, in turn, we're going to call each person in turn person. And we're going to ask for that person, are they eligible for the intervention? And we're going to say, are you eligible? And whatever rule we have specified from the experiment, it's going to say yes or no. If it says yes, and only if it says yes, then we'll perform the intervention on that person. By the way, I auto-completed, and so should you. Autocomplete is your friend. Autocomplete early, autocomplete often. Okay? That's how I filled that out. So each person in the population, we're going to say, are you eligible for the intervention, or are they eligible for the intervention? Yes, perform the intervention on them. We're calling this as if it's a function on them. And can perform the intervention. Maybe it will lower their preference for convenience store food. Maybe it will help subsidize them with some funds or what have you. And then we'll go on to the next person, ask if they're eligible. If they're not eligible, we'll just go on to the next person. Are we okay with that? That, ladies and gentlemen, is how you can perform targeted interventions. That is a pattern that you could apply on any of the models that we're building this week. And that is a pattern whose power we shall now examine. Okay? I recognize that the hour is late. I recognize that I cannot keep you. But I also recognize that this will take just a minute to show you, give you a hint of the power. Okay? I will not keep you more than 5 minutes hence. That I promise. Okay, ladies and gentlemen, my eyes are on the clock. I'm adding one more experiment. And this will be called weakened convenience store preference for those far from grocery store. Okay, sorry. Apologies. I know, you may think it will take you 5 minutes to type that.
Supermarket?
Sorry?
Supermarket?
From, yeah, supermarket, thank you. Thank you, thank you. From supermarket, yeah. Okay, okay. Now we could do the same thing on those far from parks, right? Oh, yeah, let's do that. I know, you take another 5 minutes for that name. Okay, I'm gonna add another one. It's going to be called weekend convenience store preference for those far from parks. There we go. Okay? Are we okay with that? Now you can call them whatever names you want. You can call them a very brief name. Okay. Are you ready for that? Okay. Okay. The result was ambiguous. Okay, ladies and gentlemen. So let's just do these right now. For the entire population, well, let's do it for those far from parks. This is what we'll put in. Now, okay. You notice this is eligible for intervention? By default, it just lets us say yes or no. But we're going to actually click here, and now we can specify a rule. Is that person eligible for the intervention? And here, what is the criteria? If they're far from a park. So I'm going to say if person dot distance to person dot get nearest agent of parks collection of this dot parks collection, because after all I'm in Maine. Okay. Parks. Okay. Why aren't I? Okay. Oh yeah. Fine. Person dot Maine dot parks collection. Yeah. Great. If this distance is greater than 1,500, then they will be eligible. So let me put that up on the big screen. That is the criteria for eligibility. If their distance to the park is greater than 15, the distance to the nearest park is greater than 1,500, they will be eligible for that intervention. Is that okay?
You don't need an if statement there, no?
No, it's just a rule. It's just what's called an expression, a formula that asks, are they greater than that? If so, they'll be eligible. Okay? My eyes are upon the clock. I have a minute yet. Okay? Ladies and gentlemen, perform intervention upon the person. Person dot preference for convenience store meals divided by equals 2.0. What does that mean? What does this mean? This is for the perform intervention on person. What does that mean? Or here, I can phrase it another way. Times equals 0.5. It means it equals itself times it means just like this. And you can write it this way if you prefer. But times equals means multiply whatever it is now by 0.5 and use that. In other words, halve its value. Halve its value for convenience store meals for those who are far from parks. And to complete, for those who are far from supermarkets, I could do the same basic thing, but instead of looking in the parks collection, I would look in the supermarket collection. Supermarket collection, and I would see if they're further distance than that, but I'd undertake the same preference for convenience store meals. I'd halve that value. So those who are further, we work on them and we posit that we can lower their preferences. That, ladies and gentlemen, completes this little exercise. I will put this up here, the two things. So this will be for the for the those distant from parks, times equal to 0.5. And this is for parks up top. So this is for the parks intervention, targeted parks intervention. And below is for targeted supermarket intervention. There we go. And targeted supermarket, I will just do very similar thing, except we have supermarket collection, and here the preference for supermarket for convenience store meals is the same thing. So we have two targeted interventions. One targets those who are far from supermarkets. One targets those who are far from parks. Now, this general approach could be used to look at any characteristic of a person. Is that person's history suggestive that they're buying more convenience store food than other foods? We could look at the ratio of their distance to closest supermarket versus closest convenience store. We could look at their current weight and gear it by their current weight. Make it targeted to those whose weight is over 80 kilograms. Very readily, any of those. We have a very general mechanism. We just put in some criteria involving that person, involving their history, their current characteristics, their position within a network, their position in space, and we could decide whether or not they're eligible, and then we can adjust their characteristics accordingly. But I've reached my time. Thank you very much for your patience, and I look forward to seeing you tomorrow morning. I will also present for you some results from this model on a larger scale in case you don't have time to do those yourself. Okay? So I'll show you some of the patterns that result from it, which are thought-provoking. Okay, that's all for tonight. Thank you very much.